deterministic patterns, like when there are different kinds of like config files or manifest files and such that reference various kinds of like metadata and versions and such, it can feel very tricky or non-intuitive for humans to resolve those conflicts. But after a point, if you teach those patterns to LLMs, it just tends to do quite well. And because of all the pre-training that LLMs have gone through, generally about programming languages, it also excels at, let's say, like token level sort of variability changes, code rearrangements. If you, let's say, have some kind of a call that's freeing up some memory and you want to put that below, like some if statement in some kind of a C++ file and such, models tend to also do that well. Explanations are also really helpful. At the scale of files that I have personally seen, which can be north of even 10,000 plus lines of code, with decades-long projects that I have seen with, like, let's say, Windows and like other kinds of really mature projects. Understanding a conflict chunk that's, I don't know, 80 lines of code, 150 lines of code, can feel very cumbersome for a human. And so kind of summarizing that even in plain words, that hey, it looks like it's the same function definition, one has a docstring, the other one doesn't. The definitions are slightly different, the return types are slightly different. Just helps with interpretability a lot, so that humans can still kind of be in control of that decision while utilizing what the model is suggesting. Coming to sort of hopefully the meat of the conversation here, I would love to share a few bite-sized tips and tricks that I personally got to learn through this project that hopefully can be relevant or beneficial for some of your own projects as you sort of think about certain kinds of design patterns and such. First, in terms of doing inference with, let's say, your typical LLMs, OpenAI models, or Azure OpenAI models. So I kind of got to work on this project late last fall. And so at that time, I was deciding between the OpenAI SDK or Azure AI Inference SDK. The thing is, like, these frameworks have been rapidly evolving. And so in a way, choosing, hey, which framework is in GA, like general availability, versus in public preview or in beta version, also sort of plays a part when you're talking about production-grade projects. I think today there are also other kinds of open source frameworks like MAF, Microsoft Agentic Foundation. And so the point that I want to drive here is these frameworks or Python modules are rapidly evolving. There's a lot of progress that is being done here. So just sort of highlighting what identifying what the latest frameworks are, and sort of identifying which frameworks are mature enough to sort of be used in production grade settings is what I typically have liked to go with. In this example specifically, sometimes I've seen that certain OpenAI features or tooling might first be available in the OpenAI SDK before that kind of parity is added to the Azure SDKs. And so that can also be sort of a factor in your decision based on different kinds of methods or functionalities you want to use. One particular feature that I really like from OpenAI is structured outputs, where you can make your model output, let's say, like generate an output in a very specific schema. And you can specify a JSON or like custom Python classes to specify exactly what kind of information you want your model to output. A great benefit here is, let's say, if you want to fine-tune your model, this kind of discipline in how the model should generate its answer and how do you sort of perform those comparisons or evaluate your model can be very beneficial in prepping your data for fine-tuning towards a specific output contract. And having a specific output contract can also have enable other APIs or services to consume your model's outputs downstream and process them. A con is these kinds of fine-tuned models perhaps may be disabled from agentic tool use. Like today, if a lot of people are creating agents or trying to use MCP tools and such, if you try to have like an Azure deployment, which is a very fine-tuned model, and if you try to add it to some kind of like a GitHub Copilot or any other MCP client, and you want your specific fine-tuned model to be used, it's quite possible that agentic tool usage may not work with a fine-tuned deployment, because unlike a fine-tuned model, which is only tuned to generate outputs of a specific format, under the hood of, let's say, GitHub Copilot or other other clients, they might be utilizing your model deployment to generate to generate outputs of different formats and structures, so that tools can be used downstream with them. And that sort of format might not be compatible, where the model under the hood might not generate those intermediate tokens under the hood to truly call certain kinds of tools or make certain code changes and such. So that was an interesting disadvantage that I saw of, let's say, even using a fine-tuned model for agentic usage. So this is sort of the trade-off here. If there's one thing that I would do differently in my Python implementation, it basically would be to identify what kind of official SDKs already exist out there for me to use. Back when I was implementing this project, I was naive enough to just use a coding agent and just let that go burn, in terms of just generating all the code for me. First, it tried to generate, tried to generate all of the code in one shot. It did not work. Probably wasted 2 working days doing that. Can't believe I'm saying that on record. Anyway. And then I tried to kind of clean up the slate, try to make it generate code incrementally. And then I would test, let's say, every increment or every checkpoint, and ultimately it would start working. But AI would just generate a lot of code, which would not feel very maintainable. In fact, even after going to production, I saw a few bugs in much of this implementation that I then had to go and fix. And it was much later on when I saw that rather than using your typical requests module in Python and hard-coding each API call that you need to invoke, parsing its result, trapping errors and cases like that, I could have just used the official Azure DevOps module and basically achieve the same thing in 1 line of code, or very few lines of code. And just have all of that response parsing and error trapping just abstracted away from me by just piggybacking on top of official SDKs and not reinventing the wheel. This is a design choice. And this is something that your coding agent may not tell you right off the bat if your prompt is as naive as, hey, just implement it. I am not done with my rant. Your coding agent is not going to tell you this. I was working on an Azure function which was supposed to orchestrate this entire flow of invoking an LLM and such. I asked it to code that Azure function for me. It coded it with using the V1 SDK by default, which took in a dependency and also added these JSON bindings that V1 Azure Function SDK is supposed to work with. Turns out, I then got to see when I was looking up latest design practices and such, that there's a V2 SDK for this, which abstracts away all of this code, which is sort of boxed in red, into just one-line decorators, abstracting away a lot of that setup code to sort of set up your blob client and your queues and different kinds of things. And it just makes the code so much more maintainable. As a shameless plug, I also got to write a piece for VentureBeat specifically talking about all these areas where AI coding agents, in that sense, may not be production ready. So I'm not talking about going from 0 to 1 here in terms of vibe coding projects. I'm talking about using AI for production grade code, which is secure and maintainable at a large scale. And for these kinds of scenarios, it is very likely that the model may not follow sort of either the best or the latest coding practices. For example, if the knowledge checkpoint of the model that you're using is old enough, it's very possible that it may not have been pre-trained with the most latest versions of some of the frameworks that you want to use. And so it might just output older code by default. Heck, even if the knowledge checkpoint of your model is latest enough, just with the fact that a lot of its pre-training might have been done with older versions of certain modules, can just make that model probabilistically output older code unless you specifically prompt it to use certain very latest coding practices, or avoid certain kinds of dependencies that you don't need, and just make your code a lot more maintainable. I feel like we've talked about something that I felt was interesting. Let's now talk about something that I felt is boring, but is supposed to be very important: authentication. I feel like it is one of the most sort of complicated parts of, let's say, like a large-scale software project to figure out the multiple dependencies and such. TLDR, production-grade projects, or especially large enterprises, I feel, hate secrets. And I think they have valid reasons to hate secrets. They need to be rotated manually and stored very securely, never logged and all that stuff. It creates a bunch of security vulnerabilities in today's time. And so if you can just abstract all of that away with figuring out, let's say, what kinds of managed identities you can use in production, there can be a lot of configuration that you simply won't have to like manually keep tabs on. You can piggyback on automatically managed credentials. You won't need a lot of your environment variables, and as long as you're able to understand how different kinds of permissions work, with what kind of an identity is working in your production sort of system, what kinds of permission it needs to perform certain actions, you can kind of pre-solve a lot of those like security related things before things become a problem, especially in production. Last but not the least, do you guys remember Yusuf Dikek? I think that Turkish shooter. Yeah. So the background of this, kind of unrelated to the shooter, that's just for me purposes, but is when I was dealing with a fine-tuned model deployment, I saw that Azure AI Foundry had some service, not now called Microsoft Foundry, had some service limits, where the fine-tuned, a fine-tuned deployment that I was using only had a maximum output token limit of 16K tokens. You can think about it roughly like 2,000 lines of code. Now, 2,000 lines of code in a file is probably enough. We may not see files that large in most cases. However, with the project that I'm talking about, like Windows OS, or like a decades-long project, there can be files which are upwards of, I don't know, 10,000 lines of code. I have seen files which evaluate to as much as 150K tokens even. Like, you can just imagine how massive those files might have been. And so, because I know that my model just doesn't have that much output context length to sort of generate all of those tokens of that file to resolve them, I know that my model, let's say, cannot work for that use case. And so instead of letting the model fail and waste 16K tokens with like a truncated output, what if I count the tokens of the file before I send it to the LLM? And if the number of tokens in the file just cannot fit into the output context length, I don't need to invoke my model. I can just sort of fail in a friendly way. And so there's one technically correct way of counting your tokens, and there's another very close approximation of counting your tokens. I got this insight from a friend who was working on a next edit suggestion feature, who even mentioned that even if you want to count tokens of some prompt or some string, this is a, like, length of prompt divided by 4 is a pretty good approximation, at least in English, to just count your tokens, and it can shave hundreds of milliseconds on an average per prompt, which, at least in latency-constrained applications, can be very, very valuable. And that's about it that I was planning to cover. Hopefully I didn't go very much over time. Happy to answer questions.